Hello, in this video I'm going to look at mouse interactivity in the jit.gl environment. In this patch, all of these cursors are essentially images, jit.gl videoplane objects, multiplied by jit.gl multiple. They are receiving the coordinates of my mouse in the window to figure out how much they should rotate to point at my cursor. They're also changing colors based on the position of my cursor as well. This is all possible by sending a few messages to jit.world, getting the coordinates of my cursor in the window, and applying a few mathematical operations to create a really cool visual pattern. Let's see how this is possible. And here we are again, yet another new project and another empty patch. I do have one thing with me though, and that is this image of a cursor, cursor.png. As you can see, it's just it's a picture of a cursor with a transparent background, and we are going to use this for our patch. I want this cursor to point at wherever my actual cursor is in the jitworld window. Right, so let's start with that. Let's actually display that image before we start rotating it and start getting the information out of our mouse position and those kinds of things. So I'm going to create a jit.world, let's name it mouse, and I'm going to give it the usual attributes like floating 1, so it floats, it's always visible on top, full scene anti-aliasing 1, so it looks nice, there's a nice post-processing effect, and let's give it a size of 800 by 600, so a nice resolution. Now I can just use a toggle to turn this on. There we go. All right, and now I can actually display the image here. And to do this, I need to first load the image into a jit.gl texture. And because the image file is in the same folder as my max patch, I can simply use the file attribute. I can say file, and what was the name of my image? Cursor.png, I think, right? There we go. So now I have the image in a jit.gl texture object. I can send it a bank to send out that texture, ideally into a jit.gl videoplane object, right? So I just need to tell jit.gl videoplane which rendering context it should render to, and I can also give it certain attributes like blend_enable1. This is going to make sure that the transparent background will indeed be transparent. Also depth enable 0, so when we eventually have a bunch of cursors on top of each other, they don't clash with each other and they actually look nice. And I can also already mess with the scale, so I can set scale to 0.5, make the image a bit smaller so it looks like this. Well, now it looks like a dark black box because there is no image loaded, but if I connect my jit.gl texture here and click on this button, there we go, we have a cursor in max MSP. Congratulations. Does look really nice, but it doesn't do a lot. So let's start by rotating this guy, right? And to rotate it, like I think any jit.gl 3D object, I can use the rotate XYZ message. So I'm going to pack rotate XYZ and then 3 values for 3 axes, right? So the first inlet is for rotate XYZ. I don't want to change that, but the other 2 values are for the amount of rotation on the X, Y, and Z axis. So I can rotate it on the X axis, which is not really what I want to do. I can rotate it on the Y axis, again, not what I want to do, but it's pretty cool. And I can rotate it on the Z axis, which is what I want to do because it does look like the image is rotating, right? So ideally, I want to make it so I know where my cursor is and this image knows where my cursor is in this window and it kind of points to it. So how do we do that? Well, we have to consider a few things. First of all, because I will be working with mouse coordinates in this window, I have to make sure that this window stays at 800 by 600. I don't want to be able to resize this or go to full screen. And it is easy to make sure this will not go full screen. I just have to add the attributes ESC or escape underscore full screen 0. But if I start this render, I can still change the size of this window, which again will be a bit troublesome once I actually start working with mouse position data. And it is possible to lock the window so it cannot get resized. It is a bit hard to discover how, because if you go to the help file, it is not very well documented, but there is this message in the reference that is called send window, which sends messages to the internal jit window object. And you might notice, right, jitworld is actually a combination of jit window, jit.gl render, jit.gl fizz, and a few other objects. And we can target these instances of these objects. We can really work with the attributes of jit window or jit.gl render and such objects by prepending or starting a message with send something, right? In this case, send window. And I do know from jit.window's reference that if I send, I believe, the message idle mouse, not idle mouse, but idle mouse 1, it is going to turn on the function of idle mouse, as it's going to tell me the location of my mouse, even though I'm not clicking anything in this window. And I can also use this to make sure the window does not grow or shrink, or it's not possible to drag and change the size of this window. And this is the grow attribute for the jit window component of jit world, I believe. So grow 0 should take care of it. If I click this, indeed, I cannot change the size of this. If I press escape, nothing happens. So this is fantastic. All I have to do is to make sure this always happens by using a load bank, which is going to trigger these messages each time I load this patch. Great. Now I do have this image, and it does seem to be in the same way. And I did use this idle mouse 1 message, so something should come out of the last outlet of jit world, which is called dump out. And if I use a message box, we can see what happens. Right? You see what's happening, right? My cursor, when it's in the window, it is sending out this mouse idle something 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 and a bunch of messages. And I think it's easy to figure out what these numbers refer to. Well, mouse idle is just what kind of event this is, and then I have the x and y coordinates of my mouse, right? And this is calculated from the top left. Top left is 0, 0, bottom right is 800 to 600, and ending in between is ending in between. Also interesting is the third number, which you can see if I click my mouse, it becomes a 1, and if I release the left mouse button, it becomes a 0. And the same thing with right click. So any kind of mouse click will turn that 0 into 1, so you can try to use that for some kind of interactivity within your patches. But I want to focus on the x and y coordinates right now, so let's start by isolating those. And a very standard way of doing this is to use the route object, which is going to route the incoming messages based on the very first value in that list. Right? And I know, well, my messages always start with mouse idle, so I can say route mouse idle. And if we look at what happens, we can see that, okay, now mouse idle is removed, and we only get the contents of the message mouse idle. And since I'm a bit sick of saying mouse idle because it sounds like a weird word, I'm just going to go on and I'm going to use ZL slice with the argument 2 to just slice out the first 2 elements of this list, right? So now I have my x and y mouse coordinates, which is cool, but how do we get the angle from that? How do I get my mouse coordinates and somehow end up with a value in degrees that tells how much this object should rotate to point at that mouse? Well, to do this, we have to think in terms of polar coordinates. And this is something I've touched upon and worked with in my previous videos, and you will know that polar coordinates is a way of working with points in space that is fundamentally different than using x and y or Cartesian coordinates. And how it essentially works is that I have a starting point, let's say the middle is a starting point, and I can define a point by the radius, so how far am I from that point, and the angle, so how is that point rotated in comparison with my 0, my starting location. And in this way, just as how I can describe any point in 2D space by using x and y coordinates, I can also describe any point in space using these polar coordinates. So let's do that. Let's transform this data into polar coordinates, and there's an object that deals with that, so we don't have to worry about all of these mathematical formulas and other complicated things. I can simply type in car, which will convert Cartesian coordinates to pol. So Cartesian to polar coordinates. And if I send this list, I don't need to send the values separately to each input. I can just send a list to the first inlet. It's going to give me the radius and the angle of that point. Right? That is what's happening right now. But you will notice that this, of course, starts from the middle right here, which is essentially the exact opposite of what I want. This is not the middle point from which I, calculate all the angles and rotations. That should be the middle of the screen. And I do know that it's always a good idea to normalize the coordinates, right? Right now these go from 0 to 800 on the x-axis and 0 to 600 on the y-axis. And I prefer if they go from 0 to 1 in either case, so it will be easier to work with once we have a bunch of different cursors and we have to think of even more scary maths. So there are a few ways of dealing with this problem, but since I am feeling particularly lazy, I'm going to do it very simple. I'm going to unpack. So I'm going to do unpack 0, 0, and I'm going to unpack the x and y coordinates. And then I'm simply going to use the scale object. So for the x coordinates, the x-axis, I'm going to say my values go from 0 to 800. Right, let's add that dot here so we have floating point numbers as well. But I want this to go between -1 to 1 so that the middle point is 0, all the way to the left is -1, and all the way to the right is +1 or just 1. And I'm going to copy this and say 0 to 600, the same deal, but this is for the y coordinates. And then I can pack the results, packed with a k, so only the, wait, let me add that floating number dot there. So the right inlet does not trigger the message, but the right message comes into the right inlet and the left message comes into the left inlet, and that triggers the complete message. And now you can see I have normalized coordinates or signed normalized coordinates. My values go from -1 to 1. This is going to be pretty useful in just a few minutes. And I believe this message into car-to-pols, so converting this to polar coordinates, will work just as same. Yep. Now I see from the first outlet, so this number here is a radius, the distance from the middle point. It starts from 0 and goes higher no matter in which direction I go further. And the second value, this floating point number, is the rotation, right? But this is not in degrees because, just 0, 1, 2, -2, these aren't big values in terms of degrees, but these are radians, which is another way of thinking of rotation. If you, think of a range that goes from -pi to +pi, that magical number that's 3.14 something something something. But that's a problem, right? Because my rotate xyz expects degrees, and this is giving me, well, radians. And I don't think there is an object that will do that translation in regular Max, but I can go into the help file of car-to-pol and I can very simply find the mathematical operation that's going to convert the angle in radians to degrees. So I can simply copy this, I can paste this here, and I can put the result of my car-to-pol, the angles part, here, and the final result of this operation should be in degrees, which means now I can finally plug this information to my rotate XYZ message, and it's rotating. It's not perfect, but it's rotating. But there are a few things wrong with it, right? I think if you have a keen eye, you'll notice that this is rotating in the wrong direction. So if I'm rotating my cursor clockwise, this is going counterclockwise and vice versa, and it's really not pointing at my cursor, it's pointing at this random direction. So let's start with the clockwise counterclockwise situation. Well, a very easy way to fix this would be to simply reverse the degrees, right? So let's say degrees, if they go into minus, they actually go into plus region, and if they go into the plus region, they go into the minus region. If that confuses you, essentially all I have to do is to multiply the degrees with -1, which is going to flip, it's going to reverse the direction of the rotation. So I take the result of my Cartopole operation, I convert it to degrees, and then finally I multiply it with -1 so that it rotates in the right direction. All right, and it's still not pointing at my cursor, which means I need to add some kind of offset, right? So no matter what the rotation is, always add an extra, I don't know, 20 or 100 or 120 on top of that. So, you know, it's kind of fixed. It's pointing at the right direction. So let's say plus 120. Nope, that is still not doing it. Maybe 220. Oh, that does kind of work, but it needs to be a bit more, I think, maybe 230. And there you go. So I'm adding, and this is kind of an arbitrary value. As you can see, I just did a bit of trial and error to see if that makes it point to my cursor. But adding 230 in the case of this image to the rotation in degrees to the z-axis will make it point to my cursor. And here I have it. It's a single cursor that is always pointing at my own cursor whenever it's in the window. Pretty useful. But it can be cooler, right? And that's something I always do at the end of my recording sessions, but I'm sure there is a part at the beginning of this video showing the cool end product that is not this, but it's a bunch of arrows. And we can do this, we are going to do this right now, but that means we have to deal with slightly more intermediate concepts in Mac, such as JGL Multiple and that good old jit.gen. So what we have to do is to take our JGL video plane and multiply it a lot of times so that the entire screen is covered with multiple instances of this cursor, ideally a bit smaller. And we can do this by, let me move everything a bit to the right, we can do this by using the jit.gl multiple object. Right, jit.gl multiple needs a few arguments, the name of the context, so the mouse, and how many parameters in this jit.gl video plane object I am going to control. So what do I need to control? I need to control the position of the cursors, right? So they're not all stacked on top of each other. I need to control the size of these objects, the scale of these objects, so they're not this size, otherwise it's not going to make much sense. And I need to, of course, control the rotation of each individual cursor so they can individually react to my cursor position. So essentially I need to give it the argument of 3. That was a very roundabout way of saying I need to type 3 here. But then I actually need to describe these in form of the attribute GL params, and then I need to say position, scale, and rotate XYZ. So the names of the messages I would send to JGL video plane to mess with these parameters. And then to get this working, I need to connect the outlet of JGL multiple to the inlet of JGL video plane, which will make this cursor disappear. Don't worry, that's perfectly normal. You did not destroy your patch. Now, we don't see anything here because we haven't told JGL multiple how many objects to create or their individual parameters, which is what we are going to do with these inlets. So that means we have to work with matrices. So I need to create a jit.matrix, and I know each cursor will always have 3 bits of information attached, right? XYZ position or XYZ rotation or scale in X, Y, and Z axes. So this means that my jit matrix will have 3 planes. I know it will be the data type of float 32, and let's give it, let's make it 25 by 25. Just complete arbitrary amount. So I want a grid of 25 cursors by 25 cursors. And then I'm going to put this empty jitter matrix through jit.gen. I'll do some jit.gen wizardry. And at the end, I'm going to have 3 jitter matrices telling this JGL multiple where to place these cursors, the size of these cursors, and in which direction they should rotate. So let's lock the patch, double click on jit.gen and see what we can do. Well, I should first define my outputs, right? There is already an out1 object, but I can already do out2 and out3. And you will see that jit.gen now has more outlets because it knows how many outlets it's going to have. And I can already put these here, even though they're not going to do anything yet, because inside my jit.gen patch, I have not defined what exactly is going to happen. And for now, I'm just going to make the scale, let's say 0.035, so fairly small, right? This is something I can change later. And out 3, which is going to be the rotation, I'm just going to make this an empty 3-dimensional vector, right? So all x and y and z axes are going to rotate by 0 degrees, aka no rotation. But the position needs some special consideration. Now, I'm going to do this by using this Snorm object, which is going to give me signed normalized coordinates of the input matrix. So now each cell in this 25 by 25 grid is going to have a unique value, a coordinate associated with it based on where it stands in this imaginary grid. If it's on the top left, it's going to have a signed normalized coordinate of -1, -1. The bottom right is going to have 1, 1, and the middle is going to have 0, 0, and anything in between is going to be anything in between. Because these are 2 values, and I am going to expect 3 values for the position, because this is the world of OpenGL that's 3D, I need an x, y, and z value, even if it's 0. I'm going to take Snorm, which is going to give me a 2-dimensional vector, and I'm going to just use the concat operator to add 0 at the end, which is going to make it essentially a 3-dimensional vector, where the final, the third value is always 0. And then it goes to out 1. Now, let's send a bang to this jit.matrix and let's trigger the entire operation and let's see if this works. Yep, we have a bunch of cursors that are diamond shaped for some reason, and they are all rotating together, which is not a very cool effect. I mean, it is kind of a cool effect, but I think it will be cooler if all of these cursors kind of reacted individually. Now, why are they all rotating together? Because I did not stop this process from happening. I'm still getting my mouse coordinates. I'm still converting them to angles and radians. I'm still turning them into degrees. I'm still adding that offset, and I'm sending that rotate XYZ message to jit.gl.videoplane, which is the basis of all these instances of the object. So I'm going to sever this chord, and I'm going to remove this scale 0.5, because now there is no reason to make this image tinier, because we are working with an entire grid here. And of course, now they're all black squares because I have to reinitialize the texture as well. And there we go. Okay, so now we have our bunch of cursors. They already look pretty cool. I always like this visual of grids of cursors in a window. But all right, so what do I need to do now? Well, I don't need to calculate the angle here. I actually just need the signed normalized coordinates of my mouse or of my cursor in the window. So I can send this inside jit.gen as a parameter, right? So right now I have my signed normalized coordinates. I'm just going to use prepend to add a message, add the name of a parameter at the beginning of this list. And let's call it, and I can call this anything really, but I'm going to call it mouse pos, right? Short for mouse position, of course. And if I send that information to prepend mouse pos, and I'm going to have a message mouse pos and then x and y coordinates of my cursor position. Now I can send this to jit.gen, but also inside jit.gen I have to define this parameter. I need to tell it, hey, you're going to receive a message that starts with mouse pos, and that's a special message you need to keep in mind and apply it to other operations within this patcher. So I'm going to say param, I'm going to declare a parameter, and then I'm going to give it the name mouse pos, and then its default value can be 0, 0. Right, so now when I'm doing this, it is actually sending this message into jit.gen, but of course I'm not doing anything with that parameter right now. Well, let's change that, shall we? Oh, we do have a message. Jit.gen does not understand floats. Oh, because instead of sending the mouse pass message, I directly sent the XY coordinates to jit.gen and of course it got confused. So let's send the prepend mouse pass message here. There we go. So now these error messages should stop, and yep, it's sending the message inside my jit.gen patch. All right, now we have to go into the realm of vectors and maths and all kinds of confusing things. But essentially what I want to figure out is the polar coordinates of my mouse position, not in relation to a arbitrary center point, but in relation to the each specific cursor I'm working with. Now, jit.gen works in a specific way. It will apply whatever operation I define here to each cell, right? So if I do operations, let's say I take the normalized coordinate of a cell and I compare it to my mouse position and I derive the rotation from these two pieces of data, this is going to be different on each cell. This is going to be different on each cell that gets processed by this jit.gen because the normalized coordinates are going to be different. Right, so I can work with this normalized coordinate and I can make sure the rotation depends on this normalized coordinate to make sure that each cursor behaves differently. So what do I need to do? Well, to figure out the vector that goes from wherever my cursor is to a specific cursor in the grid, I have to subtract the coordinates of that cursor from my mouse position. Right, so I'm just going to use a minus operator. So I'm going to subtract the mouse position from whatever the coordinate of my cursor is, no matter where it is in this grid. This operation is going to give me the right information. So then I can simply get the angle of that, I believe, and that can be my rotation value. So I can use car to pole here. But I have to watch out because the inlets here are not going to accept entire vectors. I actually have to split the information coming out of here into two, into x and y, and I have to feed it into car to pole separately. So is x and so is y are going to do exactly that. Right, so that goes into car to pole, and then I'm going to get the radius and the angle and radians. And I don't really need the I don't need the radius, I need the radians, right? And I actually need to convert this into degrees. So there is an object in the jit.gen environment called degrees, which is going to accept radians as input, and it's going to spit out some degrees, which I can plug into the third inlet of this vec operator that goes out of the third outlet of my jit.gen, which goes to the rotate xyz information. Right, so if I do this, let's see what happens. Nothing happens. Why doesn't anything happen in this case? Because I'm not sending this jitter matrix, right? And you can see now something is happening, but it's not reacting in real time because this jit.matrix has to be triggered probably on each frame for this operation to happen. If I'm not sending this jitter matrix into jit.gen, even though I'm setting my mouse position, I'm not triggering the calculation of jit.gen. And luckily for us, the second outlet of jit.world sends out a bang on each frame. So just connecting this to my jit matrix should make it work. All right, so this is a really cool visual. I really like the pattern that emerges, but we do have similar problems here, don't we? The rotation seems to be wrong. More specifically, the x-axis seems to work well. If I'm going right, the cursors are moving in the right direction, but up and down seems to be flipped. And there are a few ways we can try to fix this, but I think the simplest way is to go to our mouse idle operation here and simply flip the -1, 1 in the scale. So when the y coordinate comes, instead of taking the range of 0 to 600 and turning it into -1 to 1, I'm just going to turn it to 1 to -1. I'm going to reverse that operation. And that should give me, there we go, the right kind of rotation. Now I'm really targeting the right cursors. And this, whoa, this is really fun to play around with. Actually, I might play around with this more after I record and publish this video. All right, so this already looks really cool and it's already very, very, very reactive, but are the arrows pointing at the right direction? I don't think so, right? I need to maybe yet again add an offset to this. And this has to be trial and error too, I believe. So when I receive my final degrees inside jit.gen, I can simply, let's say, add 25. And that does fix it. There we go. My eyeballing it operation has worked. Now the cursors are pointing at the right direction as I'm moving my own cursor. All of them are reacting, they're rotating to point at my own cursor. And for a bit of flair, maybe something I can do is to work with the color of the object, right? Maybe I can make it so the closer it is, closer these cursors are to my own cursor, they become redder or they, change their hue somewhat. So let's go back to this jit.gl multiple and let's change a few things. First of all, well, this 3 then should be 4 because I will be controlling 4 parameters: position, scale, rotate X, Y, Z, and color. I want to also modify the color of each object here, right? And as you can see, immediately after I declare this, they all become black because they don't have any color defined. So I have to go into jit.gen, I have to create an out for, and I have to connect it to the 4th inlet of jit.gl multiple. And let's see, how can we work with color? Well, we can come up with all sorts of cool algorithms, but let's work with the HSL color space, right? HSL, also known as hue, saturation, if I can spell it right, saturation, and lightness. Right, and hue is essentially the color part, red, blue, green, and saturation is how pronounced that color is, and lightness is, well, it's the lightness or the brightness of the color. So I can create a new 3-dimensional vector, so vec 0, 0, 0. Well, actually 0 for the hue, this is the value we're going to change, but we can set the saturation to, let's say, 0.8, so it will always be 0.8, and the lightness can always be 0.5, right? So if I set these values in my operator, then even if I don't send anything to the 2nd and 3rd inlets, by default, the 2nd and 3rd values will always be 0.8 and 0.5, and I can play around with the first one. And afterwards, I can use the HSL to RGB operator to convert this into the RGB space, right? So this now, it will be a vector that gives me the right RGB values because that is what jit.gl multiple and jit.gl objects in general are going to expect. Okay, now, I need to find the distance between wherever my mouse is and each instance of these little cursors. And I already have a vector that does that, right? That this vector, so subtracting my mouse position from the coordinates of these cursors does give me some kind of vector, and I can simply get the length or the size of these vectors, and that can be the basis for my hue, right? So I can use the length operator, which is going to receive this result of this subtraction, and the result is going to go into the first inlet, and voila, we have some nice colors here, right? So now when I move this around, you can see all of these guys, all of these cursors are changing color based on that. But they do seem to be a bit reddish on the outside too, so maybe I can take the length and I can kind of lessen it. Let's multiply this with 0.5, so it's half of that value, which means, yeah, now the colors are going to be a bit more zoomed in, right? So now only the middle is very red and the complete outskirts are purplish, pinkish. Of course, you can really mess around with these values to come up with your own variations, own color algorithms. And a final nice thing I can do is to use the jit slide object, which is going to, well, it's going to apply a salvized temporal envelope follower, which might not mean something to you, but it's essentially going to smooth out the changes in the matrices. All I have to do is give it the attributes slides underscore up, let's make it 35, and slide underscore down, let's make this 35 as well. And if I send my color matrix into jit.slide, and if I send the result to the fourth inlet of JGL Multiple, now the colors are going to change a bit more slowly over time, which I believe gives it a better flair. I think it makes it look a bit nicer, a bit better, and a bit more pleasurable to look at. So there we go. It's just a few basic concepts like getting the mouse's location, changing between coordinate systems, and applying it to concepts like JGL Multiple, textures, JGL Multiplane, JGL Videoplane, sorry, JGL Videoplane, in order to create a nice grid of cursors or whatever image you want that is reactive to the position of the mouse in the window. And you can, of course, go further with these ideas. Maybe this can be audio reactive too, or maybe these guys can react to something else than the mouse, like a gamepad or a live video or some kind of sound analysis. In any case, I hope you create something fun, something nice with it, and I hope you have enjoyed this video.